Okay. No. Okay.
Okay, let's begin tonight. Let's begin now. Go ahead.
Okay. Thank you. So I want to repeat it. A warm welcome to all our friends and followers from the University of Baghdad and other chapters of the International Society of Petroleum Engineers, SPE. We are excited to launch the International Petroleum Engineers Symposium, IPES, hosted by our chapter for the first time. It is a special event that brings together SPE chapters from different countries like Greece, the United Kingdom, Germany, Yemen, Egypt, and Azerbaijan. What is in store for you? Well, we have a fantastic training program lined up, focusing on the latest in petroleum and gas engineering. You will also get to hear some amazing online lectures about the future of the oil sector. Plus, we are all about building connections and sharing our cultures with each other. Our event starts today, September 30, and runs until October 22, when we'll have a competition based on what you've learned during the event. And here is the best part. You will get a certificate if you attend at least 70% of the training and join the competition. The certificate will be awarded by our chapter and our friends from the other SPE chapters as well. Now, let's start off this exciting event with our first lecture by Mr. Mohammed Al-Jawhar. He's got loads of experience in the oil industry, and he is here to talk about reservoir performance analysis and review using OFM. And here is a small uh, experience of the presenter. Sorry, am I clear now? Mohammed, do you hear me?
Yes, it's clear. I hear you.
Okay. Sorry. For the speaker experience, he is Master of Business Administration from Marymount California University, and he has also bachelor's degree in physics from University of Basrah. In South Oil Company, over 6 years of experience in engineering, inspection, and asset integrity, conducting inspections and asset management for equipment and gears. In Rumaila Operating Organization, more than 7 years of experience as a production engineer, deputy manager, and team leader, involved in reservoir section management, production technology optimization, and implementation of new technologies. And he has also over 8 years of experience in monitoring reservoir performance data and issuing work programs for wells intervention and integrity while working at South Oil Company. So, Mr. Mohammed Al-Jawhar, you are most welcome, and please go ahead.
Thank you very much for your introducing myself. Thank you very much for everyone attending this session. Hopefully to get benefit from it for all the things we are going to talk about. So let's start with sharing the screen first. So our session today, it's going around reservoir performance analysis and review using one of the powerful tool in oil and gas industry, OFM. So OFM, one of the best tools you can use, especially for production and reservoir engineers, to identify some problems and how the reservoir is going on in terms of performance. What is OFM? It stands for Oil Field Manager. So OFM, licensed by Schlumberger, and the primary functions for it, as suggested, reservoir surveillance. As you monitoring the reservoir performance, you can identify the reservoir lacking in information or uncertainties. So you try to track every step in guidelines for your performance, and production surveillance as well, and production forecasting. One of the points you have to highlight, and because you need to know where you're going on in your production history and community production for the performance of your field. So it's a powerful suit from Schlumberger suggested, as having said that, and all that's going on about surveillance and management. This often provides user-friendly interface, enabling to view everything you need in terms of completion and well completion, well schematic, monthly production, oil well summary, production well plots, producers as a whole, as a reservoir or as individual production for each well in the field, as well as the degassing, monthly production, cumulative production, daily production for the degassing in terms of water, oil, and gas. So all these things, it's very important, very important term of how you can manage all these things together to go on in your monitoring for the field and using the perfect and the most appropriate tools to manage the environment and the sophisticated enough for experienced geoscience or petrophysics for your information. So they will use by using this tool, I mean OFM. So reservoir data acquisition required to manage these things. So where you get these the information, it's coming from spreadsheets and database you have to build, and using it dynamically in your software. This data is coming from core data, the daily production data, every data you have to put inside your software, because it's very important to QC your data, and you get the most appropriate data to build your spreadsheets and the database. I will show you that in a minute, because it's very important to know where the data come from and what is you are going to use. So these all data have to visualize. So often provides a powerful visualization tool to represent your data in terms of plots, a couple of plots and graphs and maps, 3D models. All these things can give you a perfect shot of your performance of your reservoir. So this is the very important part, because you are going to decide which the best solution for your problems, and simulation and modeling. So you can use OFM in connection with another softwares like Petrel or PipeSim. So you know Petrel, it's one of the softwares used by reservoir engineer, and the PipeSim used by production engineers. So there's Petrel, it's conducting a modeling and simulation for whole reservoir and how you can manage your reservoir and what is the reservoir characteristics. And you know, PipeSim, it's conducting deep information about what's going on in terms of the wells in the field and in the reservoir, and how you can manage them properly to have your production in terms of plateau rate and stable rate. So and real-time monitoring, because you can connect it to a real data from the field. This streams, it will give you a good indication what is the performance of your reservoir and your field, because real data, it's continuous data, and you can manage your performance of the reservoir, I mean, properly regarding that. So the another point, the decision making, because afterwards you have to take the decision, right? Because when you have all the visualization, all your plots, all your data, it's already on your table. So you got a big shot, big picture of your reservoir performance, and you have to see where you have a lack of discrepancies in your data and in your performance, in terms of reservoir performance or in terms of well performance. So these things you have to take a decision to take in place in the field itself, and you can have a good decision. When you have a good decision, you will have good performance for your reservoir. So every step it's connected to a previous one. So your decision very important, because you will in terms of your cost and in terms of your reservoir long life. The reporting, one of the tools inside OFM, so you can generate reports, and these reports, it's very important to know what exactly the performance of the reservoir, and these continuous reporting will give you a good, powerful tool to see in terms of reservoir performance. So every single integrating part of the OFM will give you in terms for the reservoir production engineer, reservoir engineers or production engineers, and everyone involved in this production and analysis for the reservoir will give you a tool to manage effectively of your performance. So the most important part, having said that, it's the database. So most of the database came from Microsoft Access. So in the upper right, left-hand side. So you have to build your access and do all the needed information to put it in your access. So this is the most important part, because it's very important when you have to visualize your data inside the OFM. So you'll get all the information in an accurate way. These data have to be collected accurately and put it inside this database. The additional function of the OFM, it's log displays and cross-section of the wellbore diagram. For example, you have to put the sizes, for example, for tubular data, sizes and the weights, grades, threads, etc. for the casing, tubing, anything you need. And then you will see a wonderful graph for the schematic of the wellbore. So every single information have to put accurately, otherwise you will get lost with your data and you have a bad decision afterwards when you go and put your logs and see where you can add perf, repair, do acidizing, fracturing, etc. So what type of surveillance you need to run? These surveillance, according to if the wellbore schematic, it's with this, for example, let's say you have to perf here, and the depth is not accurately put it inside the database, and when you present it in wellbore schematic, you will not get the right perforation interval and for the in term of depth. So we'll get something wrong and some messing up with the reservoir itself. So it will get missed. So everything should be correctly, accurately put inside the database, and then you can use it through the interface of the OFM itself. So what is OFM workflow analysis? First, you have to define. So you have to define the performance and reservoir KPIs. So you have your KPI, what you should produce from the reservoir, when and from which point, to which point I'm in terms of time, and what is the plateau rate for your production rate of the reservoir, and all these KPIs. You have to define it first. Then you can measure and compare well KPIs with performance of the reservoir and select underperformers from all the field. Then you have, we will continue to the another part, it's analyze, which is the most important part, because analyze, you have to use all the proper data. You have got it by the in terms of logs and course data, logs data, well test, everything. You have to put it inside your tool, I mean the OFM, and then you analyze your data accurately. We'll see that in a couple of minutes from the plots we provided. And then you can improve your production and improve your performance production of your reservoir. How you can do that? It's through the recommended actions for improvement. What does that mean? It means your interventions, your surveys. Well, what can you do to remove the uncertainties of the data you have? What part is missing? What is the wrong data you put and you get a wrong answer? So the improvement section is very important, because you will have to put the reservoir and long life cycle in a good condition. And control. Of course, after improving passing the improving part, so just monitor and learn from results. So what you are doing right, what are you doing wrong? So we will see and we will learn. So for each step, you have learned from your mistakes. And the most important part, you need to minimize these mistakes and errors. You know, the oil and gas industry is very expensive in terms of cost. So every intervention costs a lot, and we can lose wells, and you can damage your reservoir by taking wrong decisions. So it cannot be switching from on to off or off to on right away. So it will take time to overcome these wrong decisions. So it's very important to analyze and then to improve, to control very well. So in terms of reservoir surveillance, so reservoir surveillance is a very important part. As we mentioned, we have to monitor the reservoir performance to identify where the parts we have uncertainties, where we have something is going not quite accurate. So identify for influx, for example, mechanism and direction, and define dominant fluid flow direction, well to well, communication, production and injection surveillance. And you have production plots, whole plots. You can monitor and see, build these plots as you wish, and compare it from time to time. And you can run it through time. It's all available inside OFM. So after putting all the information, you can get this a nice plot of the grid plot, it's called, where you can see the disposal water, injection water, planned. If you have to put some wells, planned in terms of drilling new wells. So you can call it planned, producer, or unknown. So these unknowns, it's called it's unknown. You can imagine there's some uncertainty in terms of the data you already put, or you don't have. So you need to know more about all these wells to track and monitor very well, to take the decision or the correct decision, where you can put them online if they ceased or stopped, or you have something wrong with it, and convert it from unknown to producer oil, for example, or gas. So let's see the software itself. Just a minute. So this is the software interface. So you can, there's a two type of database inside the software. I mentioned one. The another one, it's created by the OFM itself. It's called OFM Workspace. So when you created the access, when you put all the data, relevant data inside the access, the OFM will create a workspace. So if after putting all the data, you will get something like this. It's called a grid map. So this grid map, where you will have all the data of the X and Y for your well locations inside your field and inside the reservoir. So you will get in the right upper hand side the category where you have, for example, well bores and completion ID, table data, decline curve analysis data, well list, and the completion. And you can play with it, and when you need something, for example, if we have to look for the zones inside the OFM, sorry. So these zones, it's a term of reservoir and conducted and targeted from the reservoir. So each one have a sub of categories as the wells inside these formations. So these intervals, for example, 10, for example, let's have one well only, and etc. So if we have 13 for 3, 2D, 2 wells, etc. So you can define each one of these wells by a color, by a name. You can play with it with, for example, you have just putting red, none. So everything you have to need to know about it, you can find it inside the software itself. So another one, you can see there are plots, reports, forecasting, and grid map, bubble map. So for example, for a bubble map, if we click bubble map, you can say select daily production for oil, and then you will have a bubble map for the production. You can run it. It will be changed over time. So you can see how it's going on in terms of production through time. So it's very important to know what is going on, what is the wells, what is the reservoir performance, and where is the most dominant part, and what is the less dominant part inside the reservoir, which formation, because you already select the zones. So you can see where you don't have any production, for example, for instance, and we have the most dominant part, and which one. So you have the legend, and you create the legend, and you can play with it and change it as you wish. So everything you will have it. I'm sorry, it's just a demo software, so not I don't have all the the data you can represent here, but I just want to give you a hint what is inside the OFM itself. So there is a database. So inside the database, there is a schema table. You can add any part of this data inside your OFM. Sorry. So as I have been saying, that's not all the things it's here. So for example, monthly production, you can add monthly production and see instantly what is the monthly production for your wells. And you have something called calculated variables. These calculated variables, it's let me show you. So this is the calculated variables inside the OFM. When you create any plot, you need to put a description for your calculation. So for example, monthly oil rate, suitable inside the OFM as a name of oil monthly, like this. And this plot name will be on monthly oil rate. So it's all about monthly oil rate for the oil coming from the well itself or from the reservoir. So another one for monthly liquid rate or CO2 injection pressure. So you can put like this as a calculate variable inside the OFM interface, and you will see when you plot it as CO2 injection pressure. So all these calculate variables you can put and play with it, and you have to you can put the short name for it, and you will get lots of information inside the OFM. So all this information, after QC your information, you will get a perfect and accurate information, and you will get the most proper decision because you have all the needed information to represent which is represented by the plots inside the OFM. So let's back to the slides. So taking example of the taking some examples from the OFM plots. So this is a grid map when you have aquifer influx in your reservoir, and you need to know what is the direction of this influx, what is what it depends on, what is going on in terms of the performance of your influx. So you need to know where is the most important part in it, where your injection goes on, what is the plan of your water flooding, what you have put and what you will get afterwards. So all these can predict and measure through the OFM, as you can see it very nicely in your plots. So let's we have this base map, and then you can identify the reservoir limits, and you have all your wells here, and you're starting your aquifer influx. What's the production injection profile for your wells, for your reservoir, and you can see when you're starting injecting and when you start your water flooding plan, you will see some wells get infected by the water, some wells are not. So there is a percentage for some wells, there is another percentage. So you can see these 0% of water. This is a minor infected by the water. And there's another part, you have more than 70% of water already flooded from your plan and your water injection. And you can take a part of your grid map or bubble map. This is called a bubble map inside OFM. So you can take a screenshot of it and see why you have these wells get the most of the water injection and the others not or less. So you can focus and try to study where you have something connected between them. Is it in the same formation? Is it in different formation? What is the production rate for it, for each one? What is the water production for each one? For how long and it takes to have like these results? Is it a month? Is it a year? What is the dominant factor plays here? Why we got all these information as a water profile from those wells? Why it's flooded already? Why it's not? So you can focus on a part of it, all of it, and see what's the decision you have to take to improve the performance of those wells and the formation in terms of reservoir. So you can see after eliminating some wells and focusing only on what is flooded, and see, for example, if it's the same formation, why those wells got not affected. This is a very minor producing water, and this is not 0%. So why all is flooded and those is not? So something, it could be there's a fault here, something it's not connection. There's no connection between those wells and nearby wells. So these all information you have to study well. It's all depend on the end user, the experience, and what is the knowledge of the end user. And you can conduct a meeting with the reservoir engineer or production engineer and see what is wrong here, what is right here, why these not affected by the water you already started injecting in the reservoir. There's another example. So we have we have edge performance of water injection. So we have edge injection wells for the reservoir, but only these wells in the reservoir unit will get flooded, and the other it's not. So after time, it's like these wells got flooded completely, and we lost those wells because there is no benefit to keep producing from water wells. So, and you can, if we back again to the previous one, you can see the other producing started to get water. So why it's not gets from the first time, why it gets afterwards, for how long? We'll start see there's a water coming from those wells. Which formation do we need to take any decision in terms of adding or removing, plug, or removing perforation and adding perforation in other formation to minimize the effect of water production from those wells. So it's will be flooded completely, and we will lost most of it, and all the reservoir will become produce water. Another example. So this is water rate and water injection rate. So it's just need to focus on the water injection profile, how it's going on in terms of the connection between wells and the performance of water of our water injection inside the reservoir, and what is the most wells become affected by this water injection profile. So you can see after 4 years, some wells, the white blue and the blue one, the white blue, it's the water injection rate, and the dark blue, it's the water rate from the producers. So it's only affect this well. After 13 years, we start seeing some wells starting to produce water, and then we select another wells to inject water and see what is the wells infected. It's minor effects after 14 years and 27 years later. So all these injected wells start to inject and keep injecting, and the other wells start to see water from their production. And after 40 years, we have increased the amount of injection and wells injected into the reservoir, and see where's the most water producing from the reservoir, and which part of the reservoir, and where the water goes inside the formation and which direction. All these things can be discussed with the reservoir engineers and production engineers, and conduct surveillance and surveys to manage this water injection profile properly. So the cumulative of the water injection, you can see, you can plot any type of the data you want and see what is the result after, and you have to take the decision according to that. So this is another example of liner in injectors. So you can see, it's very obvious from those injectors. We injected a daily amount, and there is we know the injection rate inside those wells, but there is a poor water injection from this. Why? You have to study why. So is there a skin damage, or there's a channeling, fingering? So why this well it's not injecting good inside the reservoir and in a proper way? And why we see, for example, a good production, oil production for the nearby wells, and the others is not. So, for example, let's say these wells producing 2 MBD per day, and almost these wells less than 1 MBD. So why these get the most of the water injection, and why these wells not? So it's very important to take the right decision. So what you need to, in terms of surveillance, to know why those very nearby well to water injection rate has a good, not a good production oil rate. So why these wells has a good communication with those wells? What need to improve in terms of permeability? Do we need acidizing? Do we need what type of actions, interventions to take to improve the production from those producers? Another example of a gas injection in terms of injection and producing. So the gas injection, it's the upside down triangles, and the gas rate from producers, the bubble one, the red bubbles. So yeah, and it's another example when you see there's injection and some have a good injection rate and others not, and which wells, nearby wells, I mean, get a good gas rate as producers, and the others is not. So it's another example to know where you have. So of course you have bear in mind some wells can be converted to injectors, some wells can be converted to producers. So maybe this is a good example to convert this from injector to producer, maybe get a good gas rate from it when you convert it from injector to producer. So if we see there's another, if we change the plan of our injection rate and which wells we need to stop injecting, and the other wells need to convert and start injecting from it, and what's the afterwards results from changing our plan inside the reservoir, what we'll get. So there's, we can see there's a red big bubble inside the reservoir, and the number of it increased, and the gas produced from those wells increased as we changing in our plan. So this is, we can get from the OFM. It's very important to notice and very important to track and very important to monitor well. And time by time, you will get all the relevant data according to change your plan, how to improve the production and reservoir performance. Another one for the cumulative gas injection and cumulative produced gas, when you get all the whole picture of your reservoir. So this is a very good example in terms of gas producing from our reservoir, where you can see the poor performance and where those wells is located, and why we get a poor results, and when we have a good injection rate and gas producing from the wells, and is it connected or not? What is the direction of our gas injected in our reservoir, and which the best performance in the reservoir? So these kind of question you have to ask yourself and conduct a meeting to ask the relevant people in your team, your colleagues, which they are studying these performance. This is another example of production. So in this plot, you can see there's a production, cumulative production from your reservoir, and you can see there's a declining in the reservoir pressure through time, and there is another factor of producing more water from your reservoir. So what kind of actions you have to take? So you have a production, it's not stable, but you have increase in production, but you can see from the first time you have a good reservoir, and after producing from your reservoir, it's declining. It's a very natural, very normal, and afterwards the reservoir is going up again. So what could happen in this period? So you can focus on this interval from, let's say, 2010 to 2014. So from 2010 to 2014, there's increase in water and production, and increase as well in oil production. And there is little improvement in the reservoir pressure. So what did we do to improve this reservoir pressure to get a good production rate from our reservoir? So these kinds of plots are very helpful in OFM. Another example of the production plots. So when you can see the actions taken to improve the production. So this is the gas GOR, gas oil ratio, gas rate, and oil rate. So you can see after changing and do actions, there is a little improvement in our production. So why we took a tool of actions, a step of actions, and this help us to produce in the reservoir and keep the performance of the reservoir in a very stable manner. So another example. So this one of the reservoir producing water and oil rate. So you can see there's a amount of water in the reservoir, and there is oil as well, but it's very low. And there's something happened here in this interval from 2006 to mid of 2007. So, and in mid of 2008, we did something, and we reduced the amount of water and increased the amount of oil. Again, we have declining, and we have improved it again. So this upsize rod pump. So this is the kind of decision we took to improve the production from our reservoir. We changed some properties of the rod pump, and we get oil in more than 10 MBD. As we can see, it's just struggling from 2009 to 2010, mid of 2010, between 1 and 1.5. So these kinds of actions is very important. You cannot take it unless you have a relevant data inside your OFM. My apologies. So this is another example when you have a missing data. So from 2001, end of 2001, to till mid of 2005, you have missing water production data. So this is missing what can affect your decision. So you can see there is a declining in production rate, but what's going on in terms of do you can see take a decision? Yeah, it's rising, so it will be keep rising, but rising. So why we can take a wrong decision? So I need to conduct surveys and collect data because we don't have any data. So starting from this point, we collect the data and see is it affecting the performance of our reservoir. So there is another data of water cuts, water production, and there is a declining in rising in water production and declining our production. So what is the decision? So we need to acidize, for example. Is that the right decision? We'll see when we do that. We have like this graph of increase in water, increase in oil as well, but it not last for a long time. It's almost a year. And then we need to do another thing. It's clean out and acidize again. So it's increased and increase the performance of our reservoir as well, but it's declining again. So it's continuous. Sorry. So this is another example when we have a missing water production data and we don't know where these data and we taking a decision to collect data for the water, and we put it inside OFM, see what's going on in terms of reservoir performance. This is another example when we have all the data is missing. We do something inside the performance in terms of performance of the reservoir, but we don't have any data relevant from 2002, 2007, and then we got the data. It's continuous getting it after taking the decision to collect the data relevant to the reservoir. So the missing data is it's unhelpful in terms of taking the right decision. So why we do acidizing and starting from this part? It's related to when we end, and maybe this reservoir or formation producing from formation, it's stopped for some reason, for somehow, so because we put maybe this tubing leaks. So is this tubing leaks started from 2002 or 2005? We don't know exactly, but the decision it's taking after putting the reservoir or formation online back again to analyze and place with tubing, and we reproduce from this reservoir. So all these kind of data is very important. And these data, can you see it right away in your OFM from your database and take the right decision? So it's all these continues to come to your interface of your OFM, and you have to monitor what is the performance of water rate and production rate and take the right decision. So this decision, it's not just acidizing, designing and fracturing. So you can see from this example, you have between 5 to 10 MBD producing from your reservoir, and this acidizing and fracturing increase the production to around 40 MBD. So it's good and a huge improvement in terms of production. So how can you do that? You have to analyze what you all got from your reservoir performance from the previous years and see where you can improve and how you can improve. So this, I will say, is a very good decision. Even you have a higher rate of water, but it's increased in terms of you increase your production rate. But most of the relevant decision you have to take afterwards, after you decide to acidize and fracturing, to monitor your reservoir performance and track if you have declining in your production and how you keep it stable. So this is another example of acidizing fracturing and a good improvement in terms of production from just 4 MBD to around 15 MBD. So it's a huge improvement, but you can see there is a declining in production after you fracturing your formation. Why? You have to know why you just declining very rapidly. So it's from starting, I think, from end of 2010 and to mid of 11 or first of 11, you have in 6 months declining in production rate. So is that what you plan to get 6 months in production in higher rates and then declining? So when this decline will be ends, how you can keep it stable? This is another example of converting to ASP, then back to rod pump. So why you convert to ASP? Why you put electrical submersible pump, and why you back to rod? This a decision it costs a lot, but why you just changing? Is it a bad decision taken from the production engineers to convert to ASP? What they see from reservoir performance, is it because you can get a little bit water, or what is in terms of gas production? What you will focus on this period of time and take this decision. So if you back to the reservoir performance, it's from 10 declining to about 5 MBD. So we lost 5 MBD. Is that decision of converting to ASP and then back to rods improving? I will see not. There's a struggling in getting production from this reservoir. It's still declining and declining again. So it's back again online. Why? Back in 10 MBD, even we have high water production. So what is this improvement? It's because we convert from ESP to rods. So rod sucker pump, it's take the action and take the results. We take the results from about 1, 2, 3, 4 years, almost to go back what we have already as a 10 MBD. These the same examples of this is the repair. So the repair just adding some this repair just adding some MBDs, but it's not too much, and then declining. So acidizing again and get something and back again and plug back, because we have a high rate of water production. It's minimize the water production, so it's a good decision to cut back some water from reservoir performance in terms of water production. Even we have a declining in oil, because we cut some oil from this perforation in intervals in the reservoir, but we cut in the same time amount of water. So another tool we have, you can see from the OFM, it's whole plots when we have to monitor our injection. So it's very important to monitor our production injection rate and injection profile. Why? Because we sometimes maybe we have negative skin and we need to improve what's going on in terms of production injection. And you can see there's a back to normal, and we have a positive skin again. So most of the injecting water inside our reservoir, we got nothing from or less from what we expecting. So this is another type of plots inside OFM. It's very important as we have a water flooding profile and we have a water flooding plan. This plan, it need to be improved and monitored by time. Otherwise, we'll back, as we see from here, we improve it and back to normal, and we got some bad results afterwards. So I need to improve it again. So there is another example when this improvement happened and we back to a normal after positive skin treatment. Another plots we can see from the real-time data coming to OFM. It's the monitoring of well performance. So, for example, take this example. You can see from the legend, it's the tubing temperature, annulus temperature. You can see tubing annulus temperature and pressures and the flow path of the well and the choke performance of the well. What you can obviously see in here in this plot, there is no water cuts data is missing. Either this well is not producing anything, or we didn't notice the water cut readings and take the right data continuously. So we don't have relevant data to water cut. So what is the effect of water cut for this well? Why we change the flow path from, why we have a tubing temperature declining and the annulus temperature rising? Do we change any flow path? It's look like if we change it from tubing to annulus. So as we change the flow path from tubing to annulus, the tubing temperature is declining, it's normal, and the annulus temperature rising is normal again, but we change the choke size here, the change as we intersect with the other data, it's raised the pressures, declining the annulus temperature. It could be declining in oil rate. So putting again in this condition back the choke as it is, maybe can help the production and keep it in stable condition. So this is these kind of data. So after you can see from this part, if you cut it, changing the choke, changing the temperature, the results of upper and down stream pressure for the well, playing with the choke size, affecting the pressures and affecting the temperature, and that affecting the flow rate for the well. So these kind of decisions taken by the production engineers is very important. They maybe from end of February to mid of April, so about 2 months, playing with the choke, affecting the flow rate for the well. And this is not good. So we have to put back again as it is, or despite the water cuts reading. So we need to take action about it. It should be a monitor and continuously reading for the water cut to see is that any effect of the water and the choke performance to the performance of the well. So this is for individual wells performance, and this is very important. Because individual well performance, it will help the whole picture of reservoir performance. So this is another tool and a plot from OFM you can get when you're conducting a well test and a test of pressures, and you have a production rate from another source of data. So there is a gap between what we got as a real from the field and why we got like this performance. For we're focusing here on the water cut, water rate. So you can see from this well, we have a high water rate and it's declining. Though we take some decision to maybe reduce the choke size or anything else. I don't know what's the production engineer take a decision here, but he obviously declining the production rate and declining the water rate. But there is a gap between the data from this source and the data from the tests. Even one of them wrong or both of them wrong. So we have to take the decision why we have discrepancies between these two data. Another tool inside OFM is very important. It's for forecasting. So we need to forecast our production from the reservoir because it's analyzing our reservoir performance. So we do need to predict the production of our reservoir. So this is the very helpful tool inside OFM to run this analysis and see how we can manage the performance as long as we could in good shape. So it's very important, and you can manage it accurately to take a decision afterwards. As we said, after analyzing, we have to manage and then control our reservoir. So in summary, it's all about production system analysis. So we have reservoir analysis, wells and production performance analysis, surface process and facility analysis, because all the reservoir and wells connected to the facility. So it will improve the production system analysis, which will as it's called IPES, the integrated production system capacity. So what we need to know and what we need to do, it's to maximize the asset benefits, because as we maximize it and keep it stable as we could, we reduce the cost of interventions, surveillance, extra resources we are using to analyze our reservoir performance. Thank you very much for your attending, and hopefully this get all the benefits you are planning to get from this session. Thank you. Do you hear me?
Yes, we hear you. Thank you, Doctor, for this lecture. Excuse me?
Yes.
Okay, so anyone have asked, can you unmute and ask it? Also, you can register your attend in the form in the chat. So there is anyone have a question?
There's a question in the chat. Ahmed Imad Lutfi asking you, I have one question. If possible, to show us how we can estimate the remaining reserve in a specific formation. For example, using OFM. That's the question.
Yes, it's an excellent question. Actually, as having said that, the software itself, it's connected. You can connect it to Petrel, and Petrel, it's a simulation software, and using the equation of state and using the calculated variables inside the OFM itself. So you can create the equation you want, and you can create what you are looking for. So using these things, I'm sorry, I have a demo version of OFM, so it's not easy to create that, but you can do that by yourself if you have the software connecting to Petrel and do the equation of state and get the reserves you want.
Anyone have any other question? You can unmute yourself, or you can write it in the chat box. If that's it, we would like to thank Mr. Mohammed Al-Jawhar for accepting the invitation and giving us valuable and very crucial information about reservoir performance analysis and review using OFM. Thank you, Dr. Mohammed Al-Jawhar for this valuable information, and you can register your attendance through the form and the chat box. Thank you all for attending, and that's it. We have reached the end of this session. See you tomorrow.
Thank you very much for attending. Thank you for this opportunity to present this session for all. Thank you very much.